All right, this walkthrough is on the Great Escape. Pretty interesting box. Has some server-side request forgery, breaking out of a Docker container, and using some of that Docker container web application to kind of get further information about the environment to break out of it. So I thought that was pretty cool, using Docker containers to kind of expose people to server-side request forgeries. Um, So let's give the room a look. So it is a challenge room. Whenever the first room came out, you had 3 days to complete it, and you could be entered into a raffle. Of course, it's way past the 3 days now. Um, so then the second task is just to start off with a web application, and if you can find the hidden flag. So we can open up the application. We'll also do our normal scanning and things like that. So let's get our IP address into our targets file there. And we'll start up our nmap. And we'll have a full scan and we'll do a light scan. So just two ports that initially came back, 22 and 80. We'll go ahead and get the full scans running. Meant to do the detailed, but that's fine. So we'll let that go while we look at this web application. So interesting web application. This is a little bit different than some of the other things that we've seen before, where you usually get like a blank page and then you have to kind of find a directory. So let's see if we can look at any of the source, if that's going to give us anything. So we do see a lot of JS files being loaded from a directory there. So majority of your stuff's inside the JS files. If we click on this, we can see that there is a login function. We can try some default passwords. Looks like it's the same function there. One of the things I like to do sometimes when I'm looking at some of these pages is open up the Chrome browser inspector, and you can kind of see these network requests down here. And again, this will show you where it's loading things from. When you make these requests, it'll show you. So like I just made that request there. You can see here's a 503 post. So we can see what the actual web service is pushing to the server. So it made a request, and it did that via JSON data. So if we needed to play with this, and then we got a response back, just said it was unavailable. Okay. So a normal process that we would go through then is go ahead and start doing GoBuster. So we'll do GoBuster directory URL. It's going to cap that targets list, which is the one IP. It's going to do the medium directory, and then just output that to GoBuster-port 80.txt. So if you've never seen this before, what this is kind of telling you is that GoBuster tried a couple of directories, and it thinks that we are just getting a um, blank 200 page. So that this is sometimes used whenever to kind of thwart this type of stuff, but also, I mean, it's a good security practice too. So, um, having custom design 404 pages uh, usually prevents an attacker from knowing what the underlying middleware is. So, like, if you're hosting an application on Tomcat, right, and if you don't have a custom designed for a 4 page, what happens is Tomcat will reply back with that 404 page, and it'll tell you the Tomcat version. And so then that gives you more information about like what the middleware is, and that's what you don't want. You want these generic pages to be there. So if we were to go to this URL, we can see that this page could not be found. And so this is a custom 404 page basically that they have. So that then leads you to kind of do either something more manually or kind of figure out, what's available. One of the common things to do is, go to the main page and let's see if we can just determine any of this, what underlying technologies this is running. So currently all we're seeing is, again, that it's loading JS scripts here. This file, the main file, the response. Uh, it's not really giving us anything. We can look at the headers coming back and see if that responds back with anything. We see an Nginx server. But what we're looking for is this PHP? Is this ASPX? Is this what web technology are we actually running underneath the hood here? So we can try to do like an index .html, and we see that gives us a 404 page. And what about PHP? Okay, ASPX. Oops. JS. So we're not really getting any more information out of that. Not giving us anything else. When we click admin here, again, we're not getting, we see login, but we can try login.php. Login.html. All right, so we're not getting anywhere with that. Another starting off point would be to look at the robots.txt. Sometimes that gives you an idea too. So robots.txt was invented to kind of, when Google and some other web crawlers were first scouring the internet, it was a way to kind of turn away some of the web crawlers from certain directories so that it didn't hit your server as much. But it also gives you a lot of information on what usually a web administrator doesn't want you to see. And so looking at the robots.txt, can give you an idea here. It's sort of like we see disallow API access. So we want to go look at that. We want to go see what's in there. So we'll open up another tab and we'll try that API access there. So nothing to see there. Again, we can look at the page source. Okay, nothing really there. Okay, and then the next one. So this one was commented out, but we'll go ahead and look at it anyways. Okay, so this would be a forced browsing situation. So this is probably a part of the application that you would not normally only see after you logged in. And because they're not doing any checks on seeing if you have the correct permissions to show this page, right, we're able to see it. And so, this would be a finding that I would definitely write up. We'll go ahead and inspect element. We'll get this running, and let's play around with some of these files. So we can try to click to upload a file. Let's try to upload something. So we'll look at the network here. So when we submit this, we should see. So it did take in our file. File format cannot be determined. So it looks like it just gives a blank request to that. Again, we did upload a blank text file there. I don't know if Kali has any default images really installed. Yeah. There's a screenshot. We could try that. There we go. Let's see if it figures out what that was. So there's some kind of functionality running underneath here. It's able to figure out the width and the height of the PNG. And then looking at whatever XMP is, portion of that, and displaying it here. So some kind of functionality. When we're looking at the request here, it's sending that just PNG from URL. So this is interesting. So inside the attack network, of course, it doesn't have internet access, so we can't have it directly ask for some other website. We could try to have it ask for itself and see what we get. So we do see a portion of the website. So again, this looks like it reaches out to whatever and grabs that information. So the scanning got done, and we just see still the 2 ports and not much information coming back from those. So not much there. So let's try listening on port 8443, see what we get, see if it'll actually communicate to us for our IP address. Again, you can use your little banner whenever you're on TryHackMe there. And we'll put that in here, and we're going to do on port 8443. Okay. So we did get something reaching back to us. We did see it's a Java applet. So again, now we're getting a little bit of information. So we do have the ability for it to reach back and talk to us, but we need it to do something more with that. And then execute it. And it's going to look it looks like it's going to only accept text or images. So, might not be able to get too much out of that. But we do know now it's some kind of Java applet um, inside there, basically, reaching out. So that's an interesting concept. We could also see if, oops, it can talk to itself. So course connection refused. All right, we did have that API, so we could try the API there. Let's try to connect it to that address. Because the API might just be filtering on where the request is coming from. So it still shows nothing to see here, so not really getting much back from that. All right, and then the other disallow is anything.bak.text $. So that's usually kind of to stop any request of any further extensions or any file that ends with that. So we could see if there's a well, we knew there was an index, right? So we could try. Let's try index. That's going to be .back .text. Okay, doesn't look like it was found. There was courses. Admin. Sign up doesn't look like it has it. And then login. We tried login. And then we're also on this one now, the exfil util. All right, so we got something here. So it looks like they left a backup file on the main portion of the server. What we'll want to do is copy this and put that somewhere. We could actually just wget this file and save it. So let's do that. Let's make a root directory. So again, that'd be another finding to kind of write up backup files left on the server. That happens quite a bit, actually. All right, so let's see here. Code. All right, and let's change this to HTML because that's what it looks like. Thank you. We'll make that bigger. so everyone can read it. All right, so it looks like what we got is some kind of template, right? Just defining a section, a div, it's a container, there's a title, it's a form, the placeholder, there's a script portion of this. So it's some kind of templated application. So it basically takes the response and then replaces it there. Nothing, nothing's showing me exactly like this is a specific language. It does have languages such as, syntax such as like JavaScript. This is kind of JavaScripty type things. Class instantiation, calling console, and it has a method, and then that's the data that gets fed into that method to spit out on the console. Um, this part here is interesting. API dev backup. So that's something we'll want to try and see. And maybe, again, this is something that we can only access through that. Um, so let's see if we can do anything with this. So we'll copy this URL here. We'll go back to the page that we had and submit that. And we get an internal server error. So that's something different than what we've had before. There's a message ID. So so we're talking to something else on a port. We could try not having that exfil and see what happens. So it's nothing to see here. We also could go back and add, similar to when we were doing our request here. We were submitting a URL parameter. We can see that down in the logs here. So to submit a parameter, you could do question mark URL and then equals, and we could try to see if that'll talk to us. So let's start up our server again. So clear that out, and so then now we're seeing if we're able to get from this internal system that we're accessing through there to us, and we might not be able to, but it's worth a shot. So 10, 212, 219. Remember we're on 8.4.4.3, and we'll just do test dot text. Okay, see if that's going to submit. So we're not getting any connection there, not like what we did before. So this might not have a connection out. So yeah, doesn't look like it. Response time read out. So we could try other things here. Another way that we could try this is file. So file is an actual URL parameter, and you can do like etc psswd. Okay, so something different here. We did get a contains banned words. So what about user ban ls? Contains bad words, okay. Can we we just put junk in here? File format cannot be determined, okay? So we're able to manipulate this to access some kind of request. We need to see if there's any additional commands. Is this running something to get here? We were not able to see that before. So the first time we were able to see that there was a Java agent reaching to us, and then that was getting this. What about for here? We don't have that ability to see that. So we could um, see if we can read robots. Let's do var www robots.txt. So again, if this is a standard web directory, it should have that on there. Contains bad words. We could try to see if it does any additional commands afterwards. So that's another way to kind of look at things sometimes. So we're trying multiple colons here. Trying to load different things. All right, so we are able to get some kind of output now. So we have a better idea what's going on here. So it looks like what we're trying to do is they're trying to do curl, and then we could maybe do curl like that. Okay, so now we're getting an SH error. We're getting a little bit more out of this. So I think we have the ability to kind of play with this a little bit more. If we wanted to do this maybe a little bit easier, would be to kind of look at this on the command line. So what we're doing is we're going to specify curl here, and we'll take this URL that we have down here. So let's just copy this as URL. Paste. All right, so we need to clean this up so it can work correctly. Oops, come on, there we go. Okay, so ls doesn't work. How about user bin ls? Okay, so we don't have user bin ls. We could try which ls and see if that would work. Might need to put a %20 here. So bin ls. Okay, so we did get dev note here. Let's try. So we were just doing ls. Let's try to specify a parameter now. -al. That's going to show us all the all the files and listings and directories and stuff. There we go. So we're looking at application, which looks like it's uh, a big binary or something. We could try file on that and see. Let's see what else. Let's try print working directory. So we're in /work. Okay. So we're kind of have this pseudo shell here. We can see if we have access to anything else that maybe would give us a shell. So we could do which, maybe percent like Python. Do we have Python? It doesn't look like it. We have sh. We know we have bin. Yeah, bin sh. Do we have bash? No bash. What else we could do? We could go down to the main directory. So we want to cd slash that, and then let's look at ls %20 al. So what we did is change the directory to the root directory and then did it ls al there. All right, so now we're getting something juicy. So let's clear this out here. So what we're seeing here is a clear indication that we definitely landed inside a Docker container. And what we have is an additional directory called work that was added. So we could try to read that Docker environment variables and see if they maybe put something mistakenly in there. So Docker env. And it didn't have anything. Okay. So the environment variables on the system are API dev backup root work. Let's see who we are. Okay, so we're root, but we're root on the Docker container. Got to put those %20s in between. So again, %20 is URL encoded for space. That's why I'm doing that. So we don't see like a home. There is a home directory. So let's cd into home and see if we can find anything there. So we'll take that out and then we'll cd %20 home that and try that. So we see again application can't cd into home. So let's try root. We might need to specify the slash in front. Okay, nothing in home. Let's try root. All right, so we're getting somewhere here. We got so bash history's gone to dev null, so that's not going to help us. We do see a Git directory, we see a Git config, a dot profile, and a dev note. So we could try to cat out that dev note and see what's there. So cat %20, let's do dev dash note dot text. Hey guys, apparently leaving the flag and Docker access on the server was a bad idea. So I deleted the stuff. Anyways, the password is fluffybunnies123 Hydra. Okay, so potential username and password here. Let's put that into, we'll just call it dev note on our system here. That way we have it. So if we cat that out, yep, perfect. All right, so then the other thing that we saw, in like this type of access, normally if this was like a real web server, or this container had like, you know, a SSH service running on it, what we would do is look for the SSH keys and see then, you know, basically if they left the private key on the server, and if they did, then use that, right? But we're kind of stuck with whatever they've left on the server. So currently, it's a root, and they have this application running, and all we have are these directories um, that we can kind of read out of there. And so, if you never used Git before, Git's a repository type software, and what you do is you write your code and you submit it to Git, and if you update your code, then it can do a difference of it, and then you can, you know, update that code. But it keeps a log of every one of these updates, and the reason that's important is sometimes developers, because they're doing stuff in maybe their own personal Git, they feel like they don't have to worry about security as much. So they might not be as stringent on what they put into their Git logs, and so we would want to look at that, right? So because we're in the directory where Git's at, we can do the Git command and then tell it to spit out logs, basically. So that's gonna look in that Git directory, and then each commit ends up being like this number, and the date that it was committed, and then the note that was made to do that commit. So starting at the bottom and then going to the top is, you know, usually what happens. So this was the first one, then they did this, and then they did that. All right, so we now have the commit numbers, and that the reason that you need this is that you can look at the differences between the two commits. So like this one said added the flag in dev notes, and then removed the flag and original dev notes because security, and then fixed the dev note. Okay, so if we want to see what they actually had beforehand, what we need to do then is look at that specific log. So we're going to get show, and then you have to put in that you know, commit ID basically there. Okay. So what this is, the format of is like diff, and so any of the pluses are new things that were added to this commit, and anything is minus that was taken away, basically. So basically there was dev null was taken away. They added a b/devnote.txt, and so then there was this notes. Just knock on port 42.133.7, 10.4.20, 69.69, and 6300 to open the Docker TCP port. Cheers. And then there was a flag A and a flag B, and then there we go. So we found a flag so far. All right. Let's see which one this was going to be. Can you find the hidden? That's not it. That's it there. Okay, cool. Okay. So we can look at these other gets to see if they did anything else. So that was the first one, right? And then we want to look at the second one. Oops. Messed that up. Meant get show instead of. Or did I do that right? Get show. Oh, I missed the 4. There we go. So again, looking at this, what they've then deleted now is that they deleted that portion of it, and they deleted this portion, and they basically just pointed this back to dev null. So nothing really, adding to that then. So we could read the last one too, just to validate. But again, this should be the actual dev note that we saw before. So we'll go up here and put that there. And so now, yep. So you see here, they took off dev null, they added this note here, and they put the text in here. Okay. So now we have, we should probably get the first one there. Yep, and let's put that into a file. So this is let's call this original div note. Yep. Okay. And the reason that we want to keep this is because we have to knock on these specific ports and see if something comes up from that. So how do you knock on ports? Well, we could try different things, right? We could try nmap il. Let's do p. So 42 1337 10 420 6969 and 630. Oops, forgot to put the put the IP address that it needs to scan. Cat targets. That should be right. Input list. Alright, well then I'll just put the IP address. Okay, so we tried those ports now, and then we can try that and see if we get anything else. Alright, so nothing came up on there. So additionally, what we could try to do is just go to that specific IP import there using curl. So let's try. So we're gonna do 10, 10 to 10, 83. And then let's put in the port. So that's gonna be 42. Okay, and then 1337. And then 10420. And then 6969 and 6300. 3, 1, 2, 3. Okay, try an nmap scan again and see if we got anything else. So port knocking should basically open up any hidden ports on here if we do it right. If this doesn't work, I might have to do a script or something. Okay, didn't work. All right, let's write a script. All right, so we want to do a bin SSH, target, .210 here, .83. Again, we're going to specify the ports, and that is 42, 133, 710, 420, 6969, and then 63123. So we're going to echo out those ports, then we're going to pipe it into TR. And we're going to replace that with a new line, and then that's going to execute while it's reading I. So it's just iterating through those ports basically. And then do, and then echo, we're going to say knocking on, and then I, which is going to be each one of these ports. So again, we're echoing out the ports, then we're taking out the space and replacing it with a new line, and then it's going to do this and put the value of I. So I is going to be 42 at first, then 1337, so on and so forth. All right, so then what we're actually going to, the work portion of this is going to be user bin curl, and then again, we're going to do target. So that's going to specify who we're talking to, and then I. It's going to sleep 1 second. 1, and we're going to go done. Okay, we need to chmod add executable. We want that to be that. And okay, all right, so nmap. Now we're going to, again, try this again. So sc sv p-p-o. We don't care, and then we want to just be verbose. We're hoping that this finds it this time. If not, I'm just going to see if the port's actually open. All right, it's got to go faster. Okay, so the port's definitely open. So as far as port scanning or port knocking being something that you would see in the real world, I have seen it once maybe. Again, just an admin trying to be funny or trying to make things harder. I mean, again, I've seen it been used to kind of get back into a network if they somehow lock themselves out, whatever it is, backdoor type thing. It's not something that someone's gonna be able to set up on a firewall that is a device or something like that. Um, Port knocking has to be set up um, as a program, and that program basically looks for those ports to get connection requests, and then when those uh, equal whatever you specified in the config file, then that opens up something, opens up another port or whatever that is. All right, while this is going, I'm gonna increase the time. Just do an update on this so we're good. All right. In order to save time, I'm gonna kind of jump to the next step. We'll leave the scan going, but I just don't want to eat up time um, for no reason. So what port should eventually show up here on the scan is port 2375. And again, this is not a standard port that would be open, but what will happen is the service scan and through the enumeration of Nmap will tell you that it basically is Docker, right? And so we can use, if you have Docker installed, to connect to a host and determine what's going on that host. So what we would need to do then is connect directly to our instance that we have here. So it's going to be 210. It's going to be then 83, and then we need to specify that port. So 73, 75, and then you're going to run whatever normal command that you would do. So I don't have Docker installed apparently, and I need to install it. So you saw the package there was docker.io to install. All right, let's try it again. There we go. So again, we're connecting to this IP address on that port and then issuing images command. And so what you're seeing is images on the actual remote system. And um, this is basically whatever images are running that are available on that system. Now, if we did um, PS, you should be able to see the processes. You can see port 80 there is the front end, and that's has also API dev backend, and then there's a 8080. We can only see that that's not connected to the main host there. We could also look at so these are container IDs, so we could do inspect and then look into this container, copy, paste. So this will give you all the information about that. Let me minimize this scanning. So we finally found that port. There's 2375. So looking at this, what we're seeing here is that it's an Nginx daemon for the entry point. We can see that it's running. There's the images. There's the port. We're just looking to see if there's any other volumes or anything like that. There's mask paths. There's the graph. There's the lower dir, merge dir. Exposed ports was 80. It doesn't provide a TTY. We do have user local SBIN, entry point. Okay, so that's that one. Looking at the next container. So again, PS is showing the containers are actually running right now. Again, we see it's running. It's running some daemon service, queryus.http.host. This one's called API Dev Backup. So the internal application, this application that it's running, this is one that we saw, that dot application. It's running on all listening ports, but due to the way that the container set up here, you see here this IP address and then the gateway. So Docker, what it does is if it's not exposing that container directly to the host, it sets up its own mini network. And if you run containers together, then they'll be connected inside that network. But if you spin up different containers, then they'll get their own network. And so that's what you're kind of seeing here, is that this is it's in its own 192.168.12 network here. And this one has a .3. If we were to, I think it's networks, ls. So there's the networks inside there, so you can see the different networks. So we have the host network, which is shared directly with the in air quotations internet-facing host, right? Bridge is that NAT network that things can go through, and then these are different types of networks that they were custom made, basically custom, defined. Okay, so I mean that's all good and all, but again, if we go back to the images, that's what we care about. These are the images that we've basically are using, right? So we have Alpine, we have registry, we have Debian, Nginx, Inless, SSH, front end, XFAPI, XFAPI dev. So at this point, we have the ability to kind of run stuff in container and run containers, but we need to try to elevate our privileges past that. And so this is where we can go to GTFO bins. And what we're going to look for is that we have Docker. Okay. And one of the things that we immediately start seeing, right, is that we can use the Alpine one and basically have a shell on that. So let's do